you want to start? Or?
Yeah, just I suppose we can just press start once I finish.
Now? Or? You have to press now? Or?
Brilliant, right.
So press now.
When I finish.
Okay.
Brilliant. So thank you very much. We'll start session 2, which we're trying to focus on regional and also UK-wide policy. It's a real shame DSIT can't be here, and certainly the election has caused all sorts of havoc with what speakers we could have in this session and what they can say. So many thanks indeed for everyone who has been able to say something. But we'll start off with Nikki from the Institute of Manufacturing, who's been helping do a lot of the scoping work for DSIT, although maybe I'll leave you to say what you can say. Can't say. So thanks very much, Nick.
Okay, thanks, Andrew. Thanks very much. And thanks very much for inviting me to give a little presentation today. So as Andrew said, we have gone a little bit around of what to present, but the presentation today is around the background work we did. And you may have seen the announcement about the UK National Semiconductor Institute now by the UK government. So this is just to give a little bit of the background how we ended up with DSIT announced that and all the background information we collected that led to this announcement. So just a little bit of a background. I'm not going to dwell a lot on it, but this is what we received from DSIT around March 2023. So this was the scope of the work, and what they wanted to do at that stage is to look at how they're going to grow the domestic semiconductor market. So they want to know about what sort of we have, what was needed, what sort of gaps existed, and where the government could actually play a role. And the idea also was to create a more resilient supply chain in the UK. So we had 5 work packages. The 4 top ones were technical. I'm not going to be discussing about those today, but it was around perhaps infrastructure capability you may need, around silicon prototyping, advanced packaging. This is not the commercial existing packaging, but more sort of 3D to 2D packaging. It was around compound semiconductors and the design and IP. And the 5th item in the agenda is, okay, how we coordinate all of that. So what I'm going to present today is just the final item, which is also linked to the recent announcement by DSIT. So it was a large team just from the Institute for Manufacturing. From my team, we're about 9 people working across the 5 work packages. And also had an extensive team of partners in the consortium. And you can see mainly industrial partners, the TechWorks, the Compound Semiconductor Application Catapult. We had the Photonics Leadership Group, SemiWise, Future Horizons, Cambridge Econometrics did all the econometric analysis, and then 2 universities, including some academics from Cambridge. So we had, in addition, Imperial and the University of Leeds. And then 185 different organizations within the UK and internationally. 80% of these organizations were industrial, so there was companies, both large, small, and end users, the likes of BT, for example, and Rolls-Royce, and so on and so forth. So part of that, as you see in the middle, was some international comparison that we did about, okay, what we have in the UK at the moment and how other countries do it. And what can we actually learn from what other countries are doing it, and what we could do in the UK for our own benefit. So in the international review, in essence, what we're trying to understand is what institutes exist abroad and in the UK that we could use as an example, and or other institutes that sort of support the semiconductor value chains, and also, you know, how they do it and what we can learn and what we can implement in the UK. It's not necessarily to copy, but just to get the best practices and see what is applicable here. And for that, we more or less split the work in, we call it typologies of organizations. So what we did from an initial scan is that there are two types of organizations that exist internationally. The one type is so-called RTOs, the Research and Technology Organizations. These are sort of organizations that have infrastructure. They have labs, they can prototype, the likes of IMEC, TIDL in Ireland, and so on and so forth. And they predominantly are there to support the local industry. So this is one type of organizations. And the second was a type that's called sort of, we call them innovation coordination organizations. That means they're not necessarily having facilities that you can go and access, but they do have a function of creating, let's say, and aligning the industry in common, a common future or a common roadmap, for better or worse terms. So they may do some strategic analysis to say, okay, these are the emerging markets or the emerging applications. We have, as a country, capabilities in these areas. Let's strengthen our capabilities. Let's coordinate better. Let's go for maybe bigger contracts or bigger markets or so on and so forth. So, and this is around, again, the long term. It was not what we can achieve today, but where we want to be as, you know, as a country in the future. So they take a very long-term strategic objective. And we started with a list. So DCIT, the Department of Science, Innovation and Technology that commissioned the work, had an initial listing of organizations, you know, the usual suspects like IMEC, CA Leti in France, and so on. But we supplemented that with some additional ones. So you can tell we did the typical ones. So we looked at IMEC, we looked at CA Leti, we looked at the Fraunhofer institutes in Germany. We looked also the Coordination Center in Japan, the Semiconductor Technology Center, the TIDL National Institute in Ireland, a couple of places in Taiwan, the normal ones, and some USA ones. There were not so many coordinating innovation coordination organizations around. There is one that was established in the period that we did the study in USA, the Semiconductor Research Cooperation. So we looked at how they operate. And also within the UK, we looked at some other networks or coordination organizations in other sectors who were equally complex and high value. One was the ATI Institute, the Aerospace Technology Institute, and the other was the Advanced Propulsion Center in the UK. And this is just to give us an idea about what functions what they undertake, how they coordinate with industry, and how the industry perceives them, and if they will be useful at all, you know, to have something similar for the semiconductor sector. I'm not going to bore you with a lot of detail, but just to show you a little bit the level of detail we went down. And we did that in two ways. We collected information about a lot of different stuff, about what the mission is of this organization, what the focus areas are, how they operate, how they're funded, do they have facilities, what is their budget, where is the budget coming from, how much from industry, how much from government, so on and so forth. So we went through, and these are like the top level bullet points, about 5 sub-bullet points for each bullet point. So it's quite a sort of detailed study. And we did that initially as desk research, just by looking at the annual reports or what's published already, and then targeted interviews, probably 3 or 4 interviews per institute with different functions within each, you know, maybe the strategy people, the technology people, and so on and so forth. And we did that, and we collected, in essence, just a snapshot about how these institutes operate, or these organizations. This is at the moment RTO, so this is the infrastructure specific organizations. And what we're trying to do is, if we have the 4 technical work packages, for example, do they provide silicon prototyping, yes or no? Do they do something on advanced packaging? Do they do something in compound? What do they do about the design? And as you can tell, most of the organizations do most of these things. So they have capabilities across the board, and they have been building these capabilities over a long period of time. Also, the interesting fact is, if I go this a little bit more detailed, I'm not going to go line by line, but you can tell, for example, that still even IMEC, which is probably the most well-known in the semiconductor domain, it still has about 16% of their funding coming from the local government or the sort of the Belgian government. So they're still, after, I don't know how it was established, 84, so 30 years on, 40 years on, they still rely, small percentage nowadays, but they still rely some government support for them to be successful. But a lot, actually, of the funding is coming from industry through grants or directly from industry contracts and EU funding. So it's always a blend between private and public finance for these organizations because they are very heavy, capital expensive institutes that required a lot of support for a long period of time. And if we're going for the, also for these RTOs, for these infrastructures, you have different operating models. So some organizations are very centralized, like Tyndall in Ireland is one unit, is one building with everything incorporated, all the facilities within one location. Then you have the Fraunhofers in Germany, which are fully distributed. So you have some headquarters, I think in Berlin, if I remember correctly, I'm not sure, in Berlin. And then you have about 13 other centers spread around Germany with different sort of capabilities and specialities across. And then you have the sort of semi-centralized model. So IMEC, it has the main headquarters in Belgium, but then they have other research institutes scattered around the world, and some, I think, in Scotland as well. So you could actually, we didn't go into a lot of detail of what the UK should do on that front, but it was actually seen what sort of models exist and what sort of better or worse for certain infrastructure requirements. So the key findings are that from the RTOs, from the infrastructure type organizations, are that really are designed and operating to increase the innovation of industry. I mean, academia can use them, of course, if they want, but it's really geared for industrial use and application. The funding portfolios are quite broad. They have a lot of industry funding, but still the government and other grant funds from the European Union are important part of the income, even 40 years later. They all tend to be independent and not for profit. And this is important because if you put a very heavy commercial focus on these organizations, then they become companies that are looking for not necessarily what sort of to coalesce the industry nationally, but for what's sort of important for them. The all network, and especially the European ones, tend to have an informal network of collaboration between the different ones. And it's all around knowledge exchange. So it's more about learning and investing in R&D continuously over a long period of time. And the location, as I said, is sort of varies. And for the innovation organization ones, the types like the ATI or the Advanced Propulsion Center, which is the sort of what it was the announcement around, is again, is a lot of alignment of these organizations with industry. They're industry-led. They're not, fundamental R&D-led. So they really work closely with industry to understand what sort of the requirements are now and in the future. And they use that to advise public funding about how to target their R&D. So it's not just R&D for blue sky research, which of course is useful and required, but it's much more targeted R&D to satisfy potential current and potential future markets. As such, they play a very good coordinating role in investments in innovation and also support the sectoral competitiveness. So they're trying to identify the areas where sort of a nation is good at, or the UK, let's say in this case, we use the ATI, and then target investments in these areas. So that focus is important then to coordinate the industry around key areas of focus and growth. So the UK National Semiconductor Institute announcement, this is just the bullet points that the government announced, and we're very happy actually to see that quite a lot of the recommendations that we gave are now incorporated in that. So one of our key recommendations was that the institute needs to be independent from the government. So they need to actually support it, but really to represent the interest of the semiconductor industry. And I think this is hopefully, well, at least it's announced that this is going to happen. And it needs to be, I think the specific term we had used in our recommendations is industry-led. The other term we had used, it was that it needs to be focusing on markets of interest globally, and the other, there needs to be long-term investment in the institute. It shouldn't be for the next 3 years or 5 years or follow the election sort of cycle. Because especially semiconductors are capital-intensive, long-term markets. They need to be supported, the institute needs to be supported for a long period of time. I think we had put specifically 20 plus years in there as a starting point. So I don't know if I have 5 more minutes. I have a couple of more slides to go very quickly, or I can stop here, I think. Stop here?
Depends how quickly you can get through.
It's not, I mean, some of the barriers, if it's of interest for the audience, I can continue or I can stop. So. Okay, so just to, because people did mention the skills and how you cannot find UK RF engineers or GaN engineers, I think, to get. The report also highlighted, I think, 4 or 5 key barriers. And one was the skill. And I know that Newcastle University in particular, when we did the roadshow, had a very active program of creating power engineers from apprenticeship level up to sort of PhD level. But coordination around skill shortages and gaps, which are plenty in the UK, it needs to be part also of the agenda of this new institute. And also the skills retention, how you keep people in the semiconductor sector and how you retain the skills, how you train the existing skilled people to the new processes and materials that come along. The second one that I think Scott mentioned as well is about scale-up funding and the sheer lack of in the UK for scale-up. And this is really creating a problem to the UK industry of growing and capturing more value internationally. And currently there is a clear misbalance between R&D funds and how much it goes to fundamental R&D and how much it goes to capital, basically, for scale-up for businesses. And this is sort of perhaps be corrected. There is a lack of an ecosystem. I think there are regional coordination activities, like the Northeast is one, I think, through Elaine and sort of her group of companies, and the Welsh have one, Scotland is trying to coordinate, so on and so forth. But there is not really a national ecosystem for semiconductors. Everybody's trying to optimize locally, but not nationally. And it's also very low visibility of what exists. So if a startup wants to do packaging, for example, of a particular new chip, most people don't know what exists. If one wants to do prototyping, they don't know where to go and which companies to approach to do that. And IP restrictions as well. I think, I don't remember if Vertroings mentioned about the ITR limitations. It's going to be even more serious in the future, especially for companies that work for defense applications. because you have 3 design companies in the world and 2 belong to are American, and the restrictions on military designs or using the software for military designs will be perhaps more severe. And the last one is around standardization. And when we're talking about advanced packaging and maybe getting a lead in the UK in advanced packaging, standardization of chip designs or different vendor chips when you're trying to package them is going to be a problem moving forward that needs to be sort of resolved. That's all from me, and sorry I overtook your time. So, thank you.
Thank you very much, Nikki. I'm not sure, maybe time for one quick question if anyone has got anything, otherwise we'll move on.
Just going to ask how this is likely to differ from, say, the capital centres that we have in the UK already, and where any lessons are taken from what works well and what doesn't work very well. Capital centres.
Sorry, the catapult centers.
Yeah.
Between that and the institute, you mean? Or
Just wondering how it differs, so how this institute might differ from the existing catapults that exist already, and whether any lessons have been taken from what works well with them interacting with industry and that within study as well.
I think the catapults can be part of the equation. It's not that we're going to eliminate the catapults and move on to something else. But, the catapults do have infrastructure as far as they stand, and they have taken in certain areas a leading role, strategic role. But for the semiconductors, we didn't see someone taking a strategic role per se. And I think that was the whole idea. It can be supplementary or add to.
Brilliant.
Okay.
Thank you very much.
Okay.
So with that, we'll move on to Simon Johnson from CPI.
Wonderful. Oh, timer as well. Brilliant. That's really helpful. Great, thank you. Okay, thanks very much. Thanks for the opportunity to speak this morning on a short session about integration technologies for semiconductors. I'm going to take a particular focus this morning. CPI, which I'll get on to shortly to explain what we are, has a particular focus in the area of semiconductors, not particularly making them and designing from scratch and this type of thing, but certainly we make a great deal of use of them in multiple markets and different ways. And one area that we focus on at the moment is health tech, and I want to explain the challenges of health tech really and how it can affect the way in which we can make use of semiconductors and how we need to integrate those into devices. Just 2 or 3 really quick slides about CPI and how we operate. CPI is part of the Catapult network, which we've already heard mentioned. We're part of the High Value Manufacturing Catapult, which is one of 18 or so centres across the country. And the purpose of these is to help UK industry to adopt new technologies, investigate new opportunities, this type of thing. We're partially government funded, but we do lots of commercial and collaborative R&D work as well. And the area that most of the catapults focus on is this kind of gap-filling bit between really smart ideas that come out of universities and the way that industry can make use of these. We help to fill the gap and the valley of death, as it's sometimes called, for companies in making that transition from a really smart idea to something that's commercial and working in industry. CPI actually has quite a broad focus in terms of the technologies, which I'll mention very shortly. But in terms of generic capabilities, the sort of things that we are very good at and do lots of is really supporting the collaboration and the networking of businesses together to create consortia that can solve bigger problems than maybe just a single company has. And so we have opportunities and activities in project scoping, funding, finding the right sorts of funds for these things, building consortia and so on, right the way through to helping companies with private investment. We even have a small activity which is involved in, it's called CPI Enterprises, and they can help with networking to find funding for startup businesses and that type of thing, even have a bit of funding themselves that they can contribute. And finally, so CPI is actually based in around 8 or 9 building centres around the UK. Much of it's in the northeast. We started down at the Wilton Centre on Teesside from the ICI plant there, around 20 years ago this year, in fact. And we have centres that focus on biologic drugs development. We have medicines manufacturing, and that's actually up in Strathclyde in Scotland. We have a formulations technology centre who are great at mixing chemicals in all sorts of weird ways that I don't understand, but fantastic capability. And in biotechnology, where we have some large-scale activity which can really look at the scale-up and production of biomaterials in different ways. And then the centre that I'm focused in is the Photonics Electronics Centre down on Net Park, where we have clean room capability as well as other forms of electronics fabrication and assembly. So we're quite a diverse range of different capabilities at CPI. But what I want to focus on is electronics for health tech applications and how semiconductors fit into that. Medical devices and health tech devices cover a huge range of different areas of activity. Many of us have watches that measure our heart rate and tell us how we're doing through the day, how many steps we've taken and that type of thing. But there are a vast range of different forms of health tech devices. And I've listed here a whole list. These are inquiries that we've had and projects that we've worked on over recent years. And they can be everything from a printed electronic device that is a wearable patch that can measure ECG, through to an accelerometer in your shoe that can determine how many steps you're taking, and indeed the way that you're walking. Are you walking correctly? We put pressure sensors inside shoes and things like this. So there's a whole range of different forms of devices that come into the health tech sort of area. And health tech has a particular set of challenges that arise from the way in which the devices have to be used. Bold is not very obvious on that slide, in fact, but the one I want to focus on in this presentation and discussion is the product design form factor. In health tech devices, there is a need to make devices smaller and smaller, more flexible, less intrusive, and so on. And so we're going to talk through the idea of how we can make these devices smaller and how semiconductors can help with that. Things like power sources, robustness, and so on are all other challenges that come along with health tech. Health tech is not an easy area to work in and design devices for. And if you're a company starting out in that area, there are lots of serious challenges, not least the regulatory space, which is a major challenge for many companies. So integration of high ICs into health tech devices, why is this interesting to understand and think through? As I've said, there are really sort of two key areas of health tech devices, what you might call in-body electronics. And these are things like pacemakers that should have been around for 50, 60 years probably, maybe not quite that long, but a good while indeed. There's some fantastic developments in things like cochlear implants, and there's an increasing demand for sensing, in-body sensing, measurement systems, even putting things like sensing devices inside of your arteries is projects that we've had discussions on and investigations into. So putting electronics in the body is very popular and will become more so. And clearly, if you're doing that, you need to make these devices pretty tiny and unobtrusive and don't interfere with your body in any significant way. And so you've got to worry about things like the biocompatibility of the materials and so on. But just simple things like making the devices as small as possible to be as unobtrusive and simple to make use of as possible is essential. Then on the outside, you've got a whole series of wearable electronic devices. I've already mentioned things like the smartwatch, which many of us have. I actually forgot to put mine on this morning. But they can do all sorts of smart monitoring and measurement for us. But then there's a growing area of smart patches for ECG, so things like a heart monitor that you can stick on your chest and wear for 2 weeks. It will monitor your heart, record it, maybe transmit the data up to a clinician remotely, that type of thing. and continuous glucose monitors, another growing area of wearable devices. And the challenge with these things is making them unobtrusive and something very simple for the user to use. I don't know if you've heard, but many of the drugs that are issued by pharmacies and so on, less than half of those are actually consumed by patients, mainly because we just don't bother. We just don't adhere to what we're told to do. And the same is true for devices, medical devices. Adherence is a challenge that all of these devices have to face. And so making devices that are unobtrusive, simple to wear, you forget about them, you stick them on, 2 weeks later you think, oh, I've still got this patch on me and it's still measuring my heart rate. That's the type of approach that you're wanting. So really lightweight, thin, flexible, unobtrusive devices is something that is very important for us to try to create. One of the challenges with semiconductors is that there is an increasing demand to put more and more functionality and capability into each package. So every package has got to have more and more silicon inside it. And, well, it's stunning. I find it amazing. I started in the semiconductor industry when, well, 5 microns was actually pretty tiny. You know, we could make 5-micron transistors and we were amazed. And when we were getting towards 1 micron, well, we're probably going to run out of steam soon on that, but fortunately we haven't. But that means that there are these more and more complex capabilities being packaged into these devices. And some of the new technologies for system in package, but then package on package and stacked die and all of these sort of things just make for more and more complexity. And also bigger packages, strangely enough. The things like the little RF Bluetooth modules, for example, they're quite large packages to do in the types of devices that we get asked to investigate. Rapidly running out of time, so I'm going to have to go a bit quicker. I want to give you an example of the type of device that we've worked on recently. A lot of what we do is flexible electronics. So it's conventional electronics built onto flexible substrates. You get rid of the PCB and you have a flexible piece of PET plastic or something like that. And with printing techniques, screen printing techniques, you can integrate a complete electronic system onto something flexible. This was an idea that came from a midwife who realized that it's critical, well, obviously realized it's critical to know the temperature of a newborn baby. And premature babies are terribly vulnerable. If they start losing temperature, it can be fatal very quickly. And so she wanted little bands that could be attached to the baby, but that's a tricky challenge to do. And the sort of functionality that this thing needs is quite complex. It's a complete microprocessor system. It's got to have some sort of wireless communication. It's got to have some sensing. It's got to have a power source. It's really a complex thing to try to build. And to do that in a way that is not going to interfere with the baby, which is a very tiny baby, believe me, they're incredibly small. I couldn't bring the little demo that we've got along, but they really are very tiny. What we came up with was a solution that is based on some flexible electronics, and you can see the size of the little, that's a premature baby model, so it's really only about this big, incredibly tiny. You've got to make the electronics as unobtrusive and non-interfering as you can with these sort of things. And so we use hybrid electronics sort of assemblies on flexible electronics or flexible substrates rather, to build these things. But some of the challenges, particularly for these flexible assemblies, is a larger footprint component. So something beyond 2 or 3 millimeters starts to get challenging to integrate into these flexible devices in a non-intrusive way. And so there are approaches that make use of things like bare die attach. So this is a temperature monitor on an NFC circuit. It can be batteryless, or we can add a printed battery onto this one. And this is a circuit that we've built in lots of different forms for a number of different applications. It's actually the basis of the previous one that I showed you there. But by creating an assembly with integrating a bare die directly onto the plastic substrate, then it means that we come up with a very low profile solution. The PET is about 75 microns thick. The die is something like 200, 250 microns, a little bit of adhesive underneath it, and you've got a complete structure which is less than 0.5 millimeter thick. Packaging, although device packaging has become incredibly compact, this is even better. It gets rid of a lot of the lumpiness that people don't like. But large components could be a problem too, and so there are approaches that have been investigated and new technologies for connectivity. So if you get rid of the plastic packaging around, or the ceramic packaging around your die, how do you then connect to the bonds? Well, the previous example was a flip chip approach, so had bumps on the bond pads. Just using anisotropic conducting adhesive, we were able to directly attach the bonds, the dye to the printed solution. But sometimes that isn't a good approach, and there's a few alternatives shown here that make use of things like inkjet printing, aerosol jet printing, different approaches to conducting paths from a substrate up onto a chip surface. And so these are face-up die, so you can just connect directly onto the top surface without the addition of bumps and so on. But you can make connections using simple inkjet printing. There's companies like XTPL who are producing a very impressive micro-dispense technology that can do micron-wide tracks and so on. Lots of interesting approaches to bonding these devices directly where you want them and not getting packaging in the way. And there's some very interesting anisotropic films that have come out recently that don't require thermal compression. So pretty much a sticky tape, and you can put your chip in contact with your underlying circuit. And an anisotropic conducting adhesive is one where the XY conduction is pretty much zero, and the vertical conduction is really good. Very smart technologies, and there are some new approaches that have come out recently from Sunray and Condoline that are working pretty well. We've done some experiments with those. And then there are other approaches that this is sort of for planar assembly, which is something we get quite a lot of interest in. But then there's also approaches where you might like to put your integrated circuits directly onto a 3D part. And so, for example, the top left image there is of a 3D printed capacitive sensor array that we recently experimented with and got some quite fun results with. It was interesting. But it's possible to integrate components in with that. So we've got capacitive elements. Resistors are pretty easy to make because you can just print a carbon strip and you've got a resistor. Not a very good resistor, but it's still a resistor. But then you can integrate the die directly into these sort of structures to allow measurement of the capacitance changes as you're walking around, this type of thing. And the bottom right image there shows an approach called laser direct structuring, which allows you to construct conductors onto 3D surfaces or non-planar surfaces. And again, you can attach die directly to these. So I think the message I wanted to get across really was that it's not all about packing more and more into these packages and getting higher and higher density of functionality. As Scott mentioned earlier, quite often the functionality that's needed in these sorts of devices anyway is really relatively simple. You can get away with a few tens of thousands of transistors even, or quite simple chips. Even chiplets might be quite a fun approach to these sort of assemblies. So there are different ways of building electronic systems, and these integration approaches that we've played around with quite a lot at CPI are a good alternative in some particular applications. Hope that's been of interest.
Very much, Simon. I certainly know from the point of view of the Royce Institute, whenever anyone comes to us for something, we do like to send them up to you once they've used our equipment. Hopefully they come and see us every now and then as well.
Yeah.
Time for one question before we move on, if anyone's got anything. No? Right, brilliant. Thank you very much. In that case, we'll move on. Delighted to have Guy Curry, who's now from the new Northeast Combined Authority, which has just formed as well.
Was it you telling me, Andrew, that this was designed for medical dissections, this place?
It was modelled on it.
Was it modelled on it? Right, okay.
I think it's modelled on the Royal Institution in London.
Oh, right, okay.
But hopefully, no.
I think I had a tour of this building a while ago and somebody said they used to do dissections here, so I'm already sold.
They did teach medical students.
Right, okay.
Yeah, we were sort of, it was also the precursor to Armstrong College, whenever Newcastle kept trying to have a university at all.
Yeah.
Split off and done.
Fantastic. Hello, everybody. My name is Guy Curry. I'm the Head of Inward Investment at the Northeast Combined Authority. This is going to be a very different presentation. I'm not really going to be talking about semiconductors and I'm not a scientist, I'm not a doctor or a professor. I was a little bit intimidated looking at the lineup, and everybody seems to have a doctor or a professor in front of their name. So, yes, so I'll give you a bit of context. It's quite important for the North East. We've just had a new political structure put in place. We've got a new North East Combined Authority. It was created on the 7th of May, so we're about 4 weeks old. We've got a new elected mayor. The Combined Authority was created by 5 different organisations. The previous Combined Authority in the North East was the North Tyne Combined Authority. The North East LEP, Transport North East, my organisation, which is Invest North East England, and I used to be the director of that, and I always introduce myself still as director of Invest North East England. I forget that I'm now head of investment at the Combined Authority, and the previous NECA. So those 5 organisations came together. We've got a significant amount of devolution from the government. We've got a reasonably significant budget. Anywhere, depending on who you believe, between 4 and 6 billion pounds. But that is over 30 years, so don't get too excited. We've not got huge amounts of money to spend on things like this. And we've got a range of things that we need to be dealing with. It's really important we've got an elected mayor, particularly in my world. I'll tell you a little bit about what I do soon. Because the elected mayor is that figurehead that when I'm showing businesses around the North East, particularly big, significant investors, I can take them to the mayor, and Kim McGuinness, who's the elected mayor, can talk to them and say, right, well, we can try and sort this out. We can bring this bit of funding in potentially to help you. So it's a really big deal for us because previously the combined authorities in there was a little bit, I'd say, dysfunctional. We had a combined authority covering just the north of the region, which split Tyne and Wear conurbation in half, which when you've got a big transport system, the largest metro system outside London, it doesn't really make sense. In terms of the priorities, there are 7 priorities for the new combined authority. Probably the most relevant ones for this audience are we lead on the economy, and we will be developing an industrial strategy for the North East over the next few months. It should be released in the autumn. I think, I better be careful what I say in terms of pre-election times, but I think it's probably highly likely that space and some of the associated industries will be one of those key sectors that we'll be looking to support in some way in the future going forward. As I say, we're 4 weeks old, so I can't really say much more than that at this stage. Education, skills and inclusion, that's another responsibility. We've got devolved powers for post-18, 19 adult education. We do a lot of work with schools about apprentices and things like that. So in terms of some of the skills debates that we're having, and I know there's a session this afternoon which I won't be able to attend, but the Combined Authority does have some options to sort of get involved in that in terms of providing skills for the wider sector, particularly at the sort of the entry level and school careers, things like that. And then finance and investment, £4 billion over 30 years, or 6 billion, depending the way you look at it. We have got a reasonably significant budget. Who knows what's going to happen with devolution and budgets in the future, but potentially things we might get more devolved powers or more budget. In terms of my organisation, now I'm part of the organisation, but my brand, Invest North East England, we're the regional strategic inward investment agency, so we deal with strategic inward investment inquiries that come into the region. Our job is to attract new inward investors to come. So we don't tend to deal with the companies that are already here, although they're a really important part of the messaging that we put out to businesses, talking about the clusters and the ecosystems. But we tend to be focusing on companies who are located in the States, or in India, or Europe, or even elsewhere in the UK, but not currently in the North East, so it might be a spin out from Cambridge or something like that to come up here. We work on behalf of the Combined Authority and the 7 local authorities. We've got very, very good relationships with all 7 local authorities, and we work very closely with them because they've all got capacity for business support in their areas, and also they look at inward investment as well. So we work very, very closely with them. It's a sort of matrix type operation. We work closely with the universities, which are key assets for the North East, and with business organisations and businesses, and also crucially with the Department of Business and Trade, who unfortunately couldn't be here because of the pre-election period, but they're key key partners for us, particularly when we're talking in overseas territories and overseas markets to try and attract businesses to come over here. We've got very good relationships with them. We've got a very small core team, there's only 3 of us, but we have got a wider team now, particularly in the last 4 weeks. We've got probably 3 or 4 more people in the wider team. And I think that in the future, this is going to be a priority area for the combined authority, so I can see us getting more resources. Compared to some of the sort of regional development agencies elsewhere, we're very under-resourced, but I think this is a key area, and certainly politicians in the North East like inward investment because it's about creating jobs, increasing productivity, etc. And we have a key sector focus, which I'll talk about in a bit with another slide. So how do we work? So we provide, I won't go through all these, but we provide a range of advice and support services. We can provide lots of information about lands and property and where they are, how much they're going to cost. We can introduce people and show them around the North East. We've got some good databases where we can compare various elements of the economy in the North East with other areas, sort of competitor areas, I guess, overseas and in the UK. We've got good relationships with a lot of the employment agencies. Again, when we get businesses coming over, we can introduce them to people who know about specific skills requirements for companies. We've got access to some finance. I'll talk a little bit about that in a bit. And we really, one of the key things we do is we introduce businesses to the ecosystem, to people like the CPI, to people like the universities and the colleges and some of the national innovation assets we've got in the North East. So it's a really key area for us, that. An example, I was at the Space Conference yesterday. Lockheed Martin sponsored it. We've been working with Lockheed Martin for 3 years now. And I think we've had our first call where we did a pitch to them about the North East and why they should be building satellites in the North East. That was about 2.5 years ago. On the back of that, we organised a big event, which some of you may have been at the Crown Plaza, where we brought universities. I think there were about 25 professors there. Universities, colleges. We worked with the RTC to bring supply chain companies. What Lockheed Martin wanted to know was if they built a satellite manufacturing facility in the North East, there was various bits of due diligence they needed to do. Are they going to be able to get the skills? Are they going to be able to be welcomed by the academic community and get that pipeline of high-level skills? And also access to the research and development expertise in different universities. And they wanted really just to see whether the North East had an appetite for getting something which was slightly left field at the time, because we had a really good but smallish space cluster. But we saw the potential of something like Lockheed Martin to come to the North East, to act as a catalyst, to bring in further supply chain. And on the back of that, they said, yes, we are very interested in this. So my first sort of target was to get them to build satellites. But as part of that process, they've now invested in Northumbria University, in the NEST facility in there, the North East Space Skills and Technology Centre, which is an amazing facility which is being built, should be open the end of next year. And so they've put down the roots here, and hopefully, touch wood, we'll get them to build satellites in the North East, and then who knows what can go from there. So this is just to give you an idea of some of the sectors we work in and how important inward investment is. I mean, we can send all these slides out afterwards, so you don't need to take photographs or notes. But in terms of the key areas we work in software, in financial professional business services. That's a very tall column, and lots of jobs created in that. A lot of that is on the back of sort of large contact centres, BPO organisations, things like that. But also there are sort of solicitor companies and other professional services companies coming in. Energy is a key focus for us at the moment. We've got a number of big offshore wind manufacturing projects underway at the moment, which we've been involved in, which is really encouraging. Life sciences is very important, not as many jobs created through that, but certainly we've got a very, very vibrant pharmaceutical manufacturing base, and also some really good technologies coming out of the universities, particularly in Newcastle. Automotive, you probably all know that Nissan is located up here. There's a large supply chain there. 1 in 3 cars made in the UK is made in one factory in Sunderland. We've got the first 2 gigafactories being built in the UK. both adjacent to Nissan from Envision ASEC, a Chinese company. So electrification and EV and all that stuff is a real focus for us. Advanced manufacturing, that's obviously a broad church. It covers a whole range of areas. That's obviously key and quite important for us as well. Now, in terms of the total number of jobs, this was from 14 to 23. So 9 years, there's about 36,000 jobs created by inward investment into the North East in that time. The purple is the foreign direct investment and the green is the sort of the UK companies setting up in the North East. So that gives you an idea of how important that area is for us. Where does this investment come from? You can just have a look at that. The US is absolutely the key foreign direct investment country of origin for us. That's where we get the majority of projects over that time. Japan is very important, particularly on the manufacturing side of things, the automotive supply chain, the Hitachi train factory, for example, would have been included in that. And then you get through some European countries. Quite interestingly, India, we're getting a lot of inquiries from India at the moment, so I think that sort of bar chart's going to increase quite a lot in the future. China's always been quite difficult for us to deal with, but who knows about that in the future. So that just gives you an indication of where we're getting the inquiries from, where we're getting the big projects from. And so some sort of key issues for consideration in the context of the combined authority and what we do and how we can support. I mentioned the industrial strategy. That's going to be really important to direct where we're going to be spending money on economic development and investment into different sectors. And as I said, I would anticipate that space and potentially some of the semiconductor and advanced materials is going to be an area where we'll be looking at making investments in the future. In terms of land and property, we've got something called the investment zone. I don't know if you've heard about these, but there are a number of these nationally. These are areas where we're trying to develop particular sectors where we see huge potential growth in productivity in the North East. Now, our investment zone in the North East is focused at advanced manufacturing, green manufacturing, low carbon manufacturing. There are 4 sites in the North East. 2 are related to sort of ports, and are likely to be more sort of offshore wind type developments. The other 2, there's one based around Nissan, which would be more focused on advanced manufacturing, particularly electrification. And finally, and importantly, there's one down at Net Park in County Durham, and a lot of people have mentioned Net Park already. It's where CPI are located, where Pragmatic have done a lot of work. So there's potentially going to be some incentives and some capital investment potential there through innovation, through skills, and potentially some co-investment funds. So that's something for inward investors to have a look at and say, actually, this could be an area where we're interested in working. We've still got a number of enterprise zones, and we're looking at the moment in ways, and some of them have still not been developed yet, and we're looking at interesting ways we can create financial instruments to incentivize companies who are going to come and locate on those areas. So, for example, there's a big enterprise zone near the airport, and so that's sort of work in progress. But whenever we speak to a new business, there are a number of different ways in which we can look at incentivizing them. In terms of financial support, in incentives, the last time the presentation before was talking about access to scale-up, equity funding, VCs. We spoke about this a lot yesterday at the Space Conference. A lot of VC investment doesn't come north of Cambridge. It sort of stops on the A19 there. So it is an area where we do need to make some improvements. I was in a meeting last week where we were talking about how the combined authority might be able to invest in some funding to enhance and supplement and fill some gaps in the sort of debt and equity finance packages that are available in the North East. So that's, again, something to have a look at. Grants for inward investors. We do have a grant. I run a grant which is aimed at inward investors, so not companies already here, but to try and facilitate investors to come over and locate in the North East. And that can offer, depending on the sort of project and the quality of jobs, grants of between about $500,000 up to $2.5 million in some extreme cases. It's not a huge pot, but hopefully we'll be able to fill that up and take that forward in the future. And the final thing is just skills. I mean, I know there's a separate session on that this afternoon, I think. But we have got 5 fantastic universities in the North East. providing that sort of pipeline of a lot of the things we talked about in the tea break, sort of engineers who can, you know, if they've got the aptitude, they've got transferable skills and can work into things like semiconductors. We work with the colleges and the Institute of Technology to provide those sort of post-18 skills, apprenticeships, things like that. So there's a number of things that the combined authority and partners in the North East can do and get involved in terms of skills. That's all really what I wanted to say. Not technical at all, but my details there, I've got a huge photograph there competing with these titans of industry. But yes, if anybody wants to contact me and discuss any investment inquiries, if there's a company here who's thinking, actually, from what we've heard today, we think there might be an opportunity for us to put open up a small R&D facility or a factory in the North East, come and talk to me and we can see what we can do.
Brilliant. Thank you very much, Guy. I can only apologise that all the funding stops when it hits the A14, but there we are. What a question, Scott.
Yeah, I was just interested. You mentioned a number of times the fact that it's only for inward investment into the region, and this is a fundamental issue, I think, with the UK approach to these things compared to states in the US, for example, that if you're already in the region, you're then effectively a second-class citizen and you don't get support to stay in the region, even if you've got what I think the Harrington report termed geographically mobile capital.
Yeah.
So just interested in any views on how to solve that challenge.
Well, my views on that, given we're in politically restricted times, is, this is my personal view, not a view of the combined authority, is that is a problem. And you know, the number of businesses I speak to in the North East who say, I understand there's a grant for business support, but it's only focused at new investors, is an issue for us. I've been working with local authority colleagues over the past 6 months talking about this. We've had a number of workshops. There's definitely a desire from the local authorities to help create some sort of reinvestment scheme. The big problem is, and I'll be totally honest, is funding, because, you know, in my pot at the moment, my inward investment pot, I've got £5 million. When we used to have something called Let's Grow, which was a pot of funding to support indigenous businesses in the North East expand, as well as inward investors, we were spending on average £25 million a year, and the vast majority of those were reinvestments from local companies in the North East. And I've got £5 million for everything. And so that pot would be, and I asked colleagues the other day, I said, look, give me some examples, confidential examples of projects which you think we would be able to fund through a reinvestment scheme. And one of the local authorities sent me 8 or 9 projects, all internationally mobile. And I'm thinking, well, how on earth can we support that? We just don't have the resources. So it's an issue of resources. So whether future governments will have a look at this and say we need to back companies already in the UK to help them expand, I would certainly love them to do that. That is my own personal view, not the view of the combined authority. But yeah, it is a real problem. I totally feel your pain. It's something, we had a discussion about this when I met you at the factory. It is a problem, and I'd like to turn the dial back to, you know, 10 years ago. As I say, we're spending £25 million a year on local companies.
Thank you very much, Scott. Anyone else before? No? Right, well, in that case, thank you very much again, Guy. And now we have Andy Sellers.
Sure. So it's just this button to advance, yeah?
Yeah.
Good afternoon. So I'm Andy Sellers from the Compound Semiconductor Applications Catapult. I'm going to give an overview of the catapult and also request for input into a survey that we are funding to look at the economic activity in the region. Brilliant, thank you. Great, okay, thank you. Yeah, so as I said, just Andy Sellers from the Compound Semiconductor Application Catapult. Overview of the Catapult and a request for input into a survey that we are commissioning. So just a little bit about where the Catapult sits in the ecosystem and our sort of role. We're indirectly funded by the Department for Science, Innovation and Technology. This department was formed early last year, February last year, I believe. The department funds UK Research and Innovation, UKRI. UKRI funds 9 research councils, including the Physical and Science Research Council, Research England, etc. And one of those research councils is Innovate UK. And Innovate UK supports the Catapult network. So there's actually a network of 9 catapults. And on the right-hand side, I've got a map of those. And as you can see, there's clearly more than 9 dots on the map. And it's for a couple of reasons. One is we've heard from the high-value manufacturing catapult. It has 7 centres across the UK, including CPI at Net Park. And some of the other catapults have more than 1 centre as well. The catapults all have the same roles play, and Tudor asked the question earlier about relating to the IFM study and where the catapult fits within that study. So the catapults are non-profit research technology organisations. Our role is to try and accelerate technologies into market, and all of these 9 catapults have a similar role. So, for example, the Cell and Gene Therapy Catapult is looking at new cellular treatments, which are typically £1 million per treatment, but they have very high efficacy, and they're trying to commercialise that technology. My catapult is no different in so much as we are looking at helping to take new compound semiconductor technologies, help companies commercialise them, take them to market faster, and we also work with universities and see how we can commercialise those. So our role, as I say, is to sort of sit in between academia and industry. We are part funded by Innovate UK. Innovate UK provides us with a core grant, which makes us operational. It enables us to fund labs. In my catapult in particular, we have about 100 employees now. We're structured very much like an engineering, research and development company. So about 65 of those employees are engineers. About 30 have got PhDs. We have a advanced packaging laboratory. We have a power electronics laboratory, a radio frequency laboratory, and a photonics laboratory. So we have sort of capabilities where a company can come and we can help them to develop a prototype. We fit in between academia and industry, so we can help sort of shape and inform academic research. What are the things that industry are calling for? We can also help translate that research into industry. Our particular focus areas within the Compound Semiconductor Applications Catapult, we've got 3 focus areas: energy and net zero, future telecoms, AI, and future internet. And the reason for those focus areas is that they are the areas where compound semiconductors deliver superior performance compared to other types of semiconductors. So compound semiconductors outperform. We won't replace silicon. We're very much like Scott's company. We're not here to replace the incumbent. Silicon will always dominate computation. But compound semiconductors do 3 things that silicon can't do. They do power, speed, and light. So power efficiency, electric vehicles all require compound semiconductors to extend the range of an electric vehicle. Speed, high-speed data communications require compound semiconductors. And in order to generate and detect light very efficiently, you need compound semiconductors. So for that reason, in the Catapult, we are structured as we actually have 4 engineering teams. We have a power, speed, and light team, so a power electronics, a radio frequency, and a photonics team, and an advanced packaging team. So those kind of ability to kind of package up those capabilities and help companies make advanced prototypes. I've just got sort of 3 examples here. So we had a project, a £20 million project called Escape, which had 11 companies and 2 universities, so 13 partners in that particular project. And we built the powertrain for McLaren sports cars using UK silicon carbide. So silicon carbide being a high-power semiconductor material, very good for electric vehicles. Why did we choose McLaren? Well, predominantly because they're a very innovative company and they had small volume requirements. So in order to get an innovative project to market quickly, that was the right sort of consortia. We put that consortia together. We applied for a grant from the Advanced Propulsion Centre. It was funded to £20 million. We built that drivetrain using UK semiconductors. On the back of that project, we won a £30 million project with BMW to do something similar with BMW. So the nice kind of transition here is we worked with a small niche, highly innovative company with low volume, and then we worked with a similar consortium, which is a high volume, lower cost proposition. So again, with the project with BMW, it had 3 companies and 1 university. So a smaller consortium, £30 million project to do something similar to help sort of develop the powertrain using UK semiconductors for BMW. And we've also had a number of telecom projects. This is our kind of latest area of investment. We heard from Jim, I think, on Orangan. Correct me if I'm wrong. No, we heard from Andrew on Orangan. So that was a low-cost gallium nitride mimic, one of the projects that we have put together and delivered with INEX. And another project was a secure 5G base station. So this is a quantum encrypted base station using wide bandwidth gallium nitride power amplifiers. Why are wide bandwidth important? Quite often when you put a 5G base station into a shopping centre, you have to preset the frequency that it's going to operate at. If you have a wide bandwidth power amplifier, you can do that in software, and you can switch the frequency dependent upon do channel switching dependent upon what other things are operating. So these are and that actually won an award, the IET Innovation Award last year. So there's some examples that the Catapult's working with. If you've got any questions, clearly we're delighted to work with you on other projects. So I'm now going to talk about a little bit about the semiconductor strategy and our request for a survey which is just being launched. So the UK National Semiconductor Strategy, the government published a semiconductor strategy on the 19th of May last year. It was actually launched in the Catapult. We had Chloe Smith, who was the Secretary of State at the time, launching the semiconductor strategy. And it called for a number of initiatives. And in actual fact, many of those initiatives are in flight or have already been delivered. So I think, people criticise and question, it took a long time for this strategy to see the light of day. But having said that, it has been published, it called for a number of initiatives, and those initiatives have been acted upon. So the first thing that the strategy said was to create a semiconductor advisory panel. And Scott and I were appointed onto that panel in August of last year. And the role of that panel is to scrutinise and sort of check that the other initiatives in the strategy are being delivered. Another initiative of the strategy was to commission a semiconductor infrastructure study, which we've heard from Nikki, so that was led by IFM Engage and reported into DCIT at the end of last year, December last year, presenting a number of recommendations about where UK government ought to make future investments. The strategy also called for a supply chain analysis, and DCIT commissioned a piece of work from Perspective Econometrics, which has very recently reported into DCIT. I understand that might be published in the public domain at some point in the future. I know nothing more about that at the moment, but again, that's probably, I think these 2 pieces of work are the most comprehensive analysis of the UK semiconductor industry. One about where we invest in infrastructure and one about supply chain analysis. So really in-depth analysis which has been conducted. 2 innovation knowledge centres were announced in February of this year. One is Rewire, which is led by Bristol University, and one is Cornerstone, which is led by Southampton University. The strategy called for an incubator. So the UK has actually created 19 unicorns over the last 20, 25 years in semiconductors. Not bad, 19 £1 billion unicorns. So the strategy called for an incubator, and that's actually called Chipstart UK. It's led by Silicon Catalyst UK. It was launched on the 12th of October last year, and actually has got, and it's already funded the first 12 companies, a cohort of 12 companies, and the second 12 companies will be announced next Thursday, the 13th of June, next week. So it already has its second cohort in the pipeline. Another initiative called by the strategy was for an academic strategic planning, an activity to look at where are the UK strengths in academia. That's been led by eFutures, which is Queen's University in Belfast. That has got underway very, very recently. They were actually my catapult on Monday. I believe they're at Sheffield University today or tomorrow. So they're doing a tour and they're consulting very closely with academics. excuse me, and we heard from Nikki about the IFM study, infrastructure study. One of the things that recommended was the formation of a National Semiconductor Institute. And we were very fortunate that that was announced on the 20th of May, in so much as a general election was announced on the 22nd of May, and clearly it couldn't have been announced after the announcement of the general election. So it was very fortunate that it was announced 2 days beforehand, and we were actually invited into number 10 for a roundtable to discuss that particular initiative. So that has been announced. Other than that, I have no knowledge about what's going to happen next. I think we're kind of in a holding pattern. But anyway, I guess the point I'm making here is a strategy was published, it had a bunch of initiatives, and some of the delivery of those initiatives has already either happened or has been underway. So I think it's a tick in a few ticks in the box. So now I'm going to come on to my request for input into a survey, a little bit about somebody earlier today asked me, in fact, I think it was Guy asked me about where the catapult had, what was the size of the clusters of capability around the UK. So my catapults were based in South Wales, and there's a good reason for that. There's a cluster of companies and universities which are very strong in compound semiconductors. We have IQE, we have KLA, which makes the tools, we have Microchip, we have very good universities. That particular cluster is valued at about £194 million GVA, 1,600 jobs. That data comes from CS Connected, so I've put the sources of the data. And some of the sources of the data are different depending upon the region. So there probably is an exercise here for an economist to do some sort of benchmarking to make sure there are no inflationary figures in there. But you can see that's the magnitude of the cluster in South Wales. Bath and Bristol has got a cluster of cyber security, digital chip design companies. I don't have the economic metrics for that particular cluster. The dark blue dots are where my catapult has a presence. So we opened up in South Wales. We've got some research labs. Out of 100 employees, the vast majority are based in South Wales. We've very recently opened a telecom research hub in Bristol, £6.5 million investment in Bristol. And the reason is, you can see the reason is that there's a cluster of companies there that we can work with. We have a presence in Scotland, which is embryonic, and we're just getting that off the ground. I've put the economic cluster figures for Scotland. 540 million GVA, 60 companies, 5,500 jobs. And the source for that is the Photonics Leadership Group. So again, it's potentially a benchmarking exercise to make sure that we're comparing like for like. What I'd really like to know is, we have a presence in the Northeast, my catapult. We have a sales office effectively at Net Park. And what I'd really like to know is the demands of the companies in this region and how the catapult could support them going forward. So how many companies are there here? What are the technologies they're developing? What are the barriers to developing those technologies? How can we accelerate it? How can we go faster? What sort of support should a catapult be providing into this region? We do have some figures from NEAM, so this is Elaine's team have generated these figures. 183 million GVA, 30 companies, 1,800 jobs. Not dissimilar to the South Wales cluster. And complementary, I think this is the other important thing. When you look internationally in at the UK, internationally quite often these clusters are kind of don't have the same sort of magnitude as some of the, a Taiwanese cluster, for example. So rather than talking about the UK having separate little clusters, we really need to kind of aggregate them and present that as an international picture. And that needs a degree of coordination, and also we need to look at where the complementarities are rather than the competing elements. But you can see there's complementarities between the Northeast with optical, satcoms and defence, and what's going on in South Wales. So there is a degree of complementarity. And just lastly, I've got the figure there for South Devon. Again, Photonics Leadership Group. So the very last slide is my request for information. Now, there was a study done, 2021, I think Elaine said it reported, a landscaping report of the region. The value, the GVA, the number of companies, what technologies they're developing. So we are refreshing that. It's being funded partly by the Catapult and by Business Durham. I believe a contract will be awarded shortly to a company to do that piece of work. I implore everybody to contribute it. I know we'll get surveyed to death. So this is my plea, is to contribute to the survey to say, what is it, what are the technologies you're working with, what are the magnitude that we can deliver, how can we help, what are the barriers that are stopping you from delivering those, and then in which case, having gathered that report, it really helps Catapult to make the case to support the region. And you saw in the previous map that we've got locations in other parts of the UK, so that will give us the evidence to expand and to support those companies in this particular region. And those bullet points are just the ones that I copied out of the quote for the contract. So they're the things that this piece of work is going to be looking at. And that concludes. Thank you.
Thank you very much. That was a fantastic overview. One quick question before we move on. If anyone's got anything, otherwise, no. Well, brilliant. Thank you very much, especially coming all the way here.
Sure.
So we're running slightly behind time, but we do have a few volunteers for our panel. I think I'm not sure if everyone's happy staying where they are, sitting where they are rather than moving about. Yeah, that's fine. So we've got Scott White, Andy Sellers, Alton Horsfall, and Rob Farr as well. Rob, there we are. Rob's at the back. Maybe if you want to come closer down to the front one. There we go. So a few, and many thanks as well for Nikki for helping out with a bit of the background for this. But we'll ask our panelists a few questions, and first, and then we can maybe have a few minutes of discussion. But perhaps this is something to then carry on over lunch as we go for that. So the first thing we have, and we can start with Andy and Scott. But what do you think the North East can do or take advantage of regarding the current UK semiconductor strategy?
Do I need the microphone? Okay. So the semiconductor strategy kind of identifies three particular strengths in the UK. It identifies research development, compound semiconductors, and design and IP. So, and the reason why those three areas were identified in the strategy, I think, is because when the government was putting together the strategy, they realised that we're not going to build the arguments for building a silicon fab just don't really make sense. And they were trying to find out where the UK had real strengths of strategic competitive advantage, where if you back those horses, you're likely to have a bigger impact rather than going head-to-head internationally. So I think the first thing is to focus on those three areas that are in the strategy, because they're the ones which are clearly the government has identified, and probably for good reason. The universities in their area are very strong, so that's the R&D element. I think on the compound semiconductor, I sort of extend the hand of friendship to Indian zinc tin oxide as a potential compound semiconductor. I think it's identifying those particular materials where we have a competitive advantage as well, where we can compete internationally.
Maybe just to add to that, so yeah, secondly, I think that need for focus is obviously important, but I think there's also, importantly, the need to focus on collaboration across sectors, and I mentioned this, that the UK... Turn it on. The UK sectors are too small by international standards to try and do things, in too isolated a way. So I think there's obviously a need to balance focusing on where there are regional strengths or specialities or things we want to do here, but not getting into a parochial view of saying, well, actually, we're going to do all of this here, or we're only going to do this here, because the UK as a whole together is still marginal in terms of having enough critical mass to really compete effectively internationally.
I think I hear these things. I think it's always interesting, people talk about ideas coming out of universities. It's how universities make enough of something to get it out into the big wide world. Clean rooms in universities are closing, becoming ineffective. And there's actually a critical point there of how researchers in universities can do enough to be taken seriously by people outside. And yeah, I'd echo the comments made by Scott and Andy. We concentrate on what we're good at. We concentrate on the things that we can do. There's a nice big niche where we can go and play. And the competition doesn't look like TSMC.
Go over to Rob. I guess one of the things that the North East needs to look at is the history of manufacturing here. It's been done before. I was part of that Fujitsu Siemens 1990s brigade who came out of universities, came to the North East, and within a few years there was an immensely skilled workforce put together right through from shop floor operators to technicians, equipment engineers, process engineers. And there needs to be a little bit of looking back on that and going, okay, how did it happen in the past? How can it happen again? Because it's been done before and it doesn't need that wheel reinventing, basically.
Brilliant, right. So that's question number one. And certainly, yeah, it's great to hear about clean rooms. Of course, we've just built Cab 3 in Cambridge, and this is going to be a bit of rationalisation probably, but certainly, hopefully you'll cover the Royce clean room training programme as well, which is trying to support skills across the UK for that as well. So how can we coordinate better regionally? What is good or could be improved with the current coordination initiatives? So I know you're based down in Leeds. I don't know if, yeah, we'll skip this one. So we'll pass back to
I suspect that this is probably the number one task of the National Semiconductor Institute's job, would be my guess. I think it's starting to almost have it's not even born yet, but I think it's already starting to, DCET are starting to think about what it, there's a list of things that need to be done, and there isn't a body that does those things at the moment. So I think on the formation of the Institute, one of the things it ought to be doing is not just coordinating regionally. I mean, that's one thing to do, but it's to coordinate nationally to make, to see what is happening in the North East, how that complements Scotland, how it complements South Wales, and then to look internationally as well. I mean, there's no point in backing something if somebody else is doing something else internationally at greater scale. You're just going to fritter away your competitive advantage. So there's a case of looking where the UK regionally and across the UK strengths, benchmarking that internationally to say where we really are better than other countries, and then maybe having strategic partnerships with those countries. So in other words, the US does X and the UK does Y, and it balances out. I think I think that's probably a job for my gut feel is that that's a job for something like the Institute to do.
Nothing to add.
Yeah, tricky one. I would say the first thing from the North East perspective is, thanks Elaine, you do all this, we don't pay you, and you do all this effectively in your spare time for NAFOL, and we really ought to find some way of supporting you in what you do, because everybody in NEAM recognises that we're all together in the same room because you round us up every 3 months and force us to. Sometimes she offers biscuits, other times she offers threats. So there is something there that, as a region, we need some level of support to actually bring us all together. And we are doing it on a shoestring, and it really works at the minute, but we could do so much more. But then the question is, why just us? There's people in South Wales, there's people in Scotland, there's people in, geography's never been my strong point, some other parts of the UK. The UK is only this big, remember? We need to think regionally, as in the bit inside the wet bit. We're all together, and we all have to work together, otherwise we're going nowhere. But do give Elaine some money.
I could add a little bit to that, and that is, so the cluster in South Wales is, you've seen it's around about the same size as the cluster here, and I think the big thing they did was just to galvanise and get their act together early, and then and initially that was all kind of motivation. To your point, it was kind of, done over a cup of coffee with no budget and kind of meeting and self mobilisation. But then what they did was they applied in for I think it was a UKRI Strength in Places Fund, and that has funded some regional projects, but it's also given it a bit of management, structure and communications. So there's a little bit of a lesson that kind of, they were just a little bit ahead of other regions in terms of doing that. But there's certainly, I agree with what I was saying, kind of the coordination thing. If you're just doing it on a shoestring and in your spare time, it's not quite the same as having some sort of organisational structure and a bit of marcoms and what have you to support you. Yeah. Yeah, sure.
And our final one is, how can the Northeast bring in more foreign investments in general, and perhaps which areas or markets, applications, materials should we really be focusing on?
So, at the risk of being a bit of a broken record, I think I'd start by saying it's the wrong question. We need to maximise the amount of investment in the region, and that is a combination of what we bring in from outside and how we maximise the scale up of what's here. And actually, they're inextricably linked, because there is only a motivation to invest from outside if there's going to be long-term support for that to continue to grow. Otherwise, it's a bit of a dead-end investment decision from a rational perspective. So I think there is the obvious question to Guy's point of amount of funding. That's a hard one to get away from, particularly in the semiconductor industry, where every other country in the world is putting so much government support financially behind it. But beyond that, there are these sort of softer factors, and I think we've touched on probably the two most important from my perspective. We've touched on there's the sort of coordination of activities between the sector, which I completely agree with what Andy said. The reason there's been it came out very clearly as a recommendation from the IFM study, and it's almost the one bit of the study that had, I think, no pushback from any of the community. There was all questions over, well, do we really need silicon prototyping? Which bits of compound semiconductors should be focusing on? There was lots of debate around lots of things, except for the fact that we need this coordinating body, because it will provide the structure to actually coordinate a lot of what's happening. And I think that also specifically is focused on that bit about investment into the sector, which I think you could then play into sort of investment into the region as well, is you need that coordination to be able to say, this is what we've got within the Northeast. We've got a set of facilities at CPI at NetPark that most people in the UK don't know about, let alone anybody outside the UK. There's capabilities at INEX, for example, similar case. So making sure these are understood and known and publicised, I think is sort of one thing. So positive thing is, there's hopefully, the right progress in that direction, as long as it doesn't get kiboshed by the election. The other key one, again, that's come up today is skills. So, to the point about, this has been done before in the region. We know there's the ability to build the skill set we need. We need to replicate that all over again. Equally, we need to try and make sure, how do we replicate that so it doesn't end up the same way that it did 20, 30 years ago. That, and part of that is about the government support and ensuring we keep this top of the agenda and that it doesn't just drift away because actually, we don't have the supply chain crisis we had a few years ago, so everybody gets a bit comfortable. But it's also making sure that there's that long-term view around the skills pipeline.
Brilliant. Well, thank you very much. There we are, people.
Yeah, I guess it's focus. We're not going to be a region or even a UK that builds a TSMC. We're not going to be a DRAM factory anymore, churning out, what was it back then, 4 megabit ones. And it's going to be picking those battles where we can add value, where we can find gaps in the market and make it a real Northeast or UK thing, that if you want this, you come to these certain areas. The skills bit is something I'm passionate about. I think the skills are there. I think the training facilities are there. I agree. It's the coordination, both locally and nationally, to get all that working.
I just want to generally add one point, which is around the focus bit. We do need to focus, and I support that. The only thing that concerns me whenever this discussion comes up about is if we'd had a focus strategy 15 years ago, pragmatic wouldn't exist. So I think there's an interesting opportunity in the UK that focus is not just defining what we are going to do, it's defining what we don't do. So we're not going to do high-end silicon manufacturing, for example, but actually within that, how do we also leave open the potential to do the stuff that is a bit left field, where actually, potentially one of the areas where the UK can be most disruptive because we are not, we don't have the incentives to follow the herd of everywhere else because we don't have that established industry. So.
No, I don't need a microphone. I mean, I think the opportunity and the good news is that for 40 years, Moore's Law has been, at work. Whenever anything like that happens, you get a pyramid effect of the biggest companies being able to benefit from their. There are now 40 different technologies. I don't know. I'm pulling that number out of the air. There are a hell of a lot of new technology directions, many of which have been talked about today. We don't know which ones are going to win, but we actually have an opportunity in the UK because of all the research, etc., because of the work people in this room are doing, to really grab some of those. But we can't decide now which ones are going to win, other than say compound semiconductor. That'd be my view.
Brilliant. Right. Well, I think we're heading towards lunch. Sorry, it is. I feel people are getting restless. So thank you very much for our panelists' quick thoughts. Hopefully they can provide a few discussion points during lunch, and we'll look forward to seeing you again at 2 o'clock here. I think if lunch is outside, do feel free to bring it up to the Wood Hall as well. There's tables there. It's a far bigger room, so you can go and mingle. We recently had our annual dinner there as well, so there's another thing for membership. But brilliant. Just to say thank you very much again to Nikki, Simon, Guy, and Andy. Fantastic presentations. Thank you very much.